Hi everyone, welcome to This Week in Space Science. I'm Michael Baltimore here with the Executive Director of the Coca-Cola Space Science Center, Sean Cruz. And Sean, how are you?
I'm good, Mike, thanks. How are you doing?
Pretty good today. I know we had a lot of information today to get to our viewers out there. Well, I think we need to just jump in. You know, this show, This Week in Space Science, is all about bringing information to our viewers about what's happening on Earth, NASA, also out in space,
yes,
and even beyond.
And beyond.
Okay, there you go.
Whatever that means.
Whatever that means and wherever we go with that. All right, so our first story. Now, this was in the news. I actually saw it on the morning talk shows this morning.
That's right.
There was a climate satellite that failed.
Even though I don't always get to do the most current news,
right,
once in a while, like today, I get to bring you a story that's literally hot off the press. In fact, when I was doing my show prep this morning, this story was kind of unfolding real time. Right. This morning there was a climate satellite. It was called Glory. Right. It was being launched by a NASA rocket called a TWiSS rocket. The TWiSS rocket was launching fine. The launch was going well until it got to the point where the nose of the rocket, which is called the fairing, the nose covers up the payload. That fairing was supposed to open up and release the satellite into orbit, and it didn't work. So the fairing remained closed. And right now you're seeing the launch of the rocket itself. This is all when things were going well.
This looks good so far, right?
Yeah,
okay,
it's a four-stage rocket, and of course this would have been during the last stage of the rocket's flight. About 5 minutes into the flight is when this fairing is supposed to open up, and that payload is supposed to be shot out of that nose cone area.
So it's really at altitude. I mean, it's getting up there. It's almost ready to go into orbit.
It was the last stage that would push it on into orbit.
Okay.
And that's what failed. I shouldn't say the stage of the rocket didn't fail. It was actually that covering that didn't separate. And since that covering didn't separate, that last stage of the rocket was not powerful enough to lift the extra weight provided by that fairing and the payload into orbit. And so it's not like they were able to get it into orbit and they could figure out what to do about opening it up later because that extra weight was there. It just didn't have enough oomph to make it into orbit, which means it came back down.
It's going to come back down in a sense. Now, is it going to burn up on a reentry, or is it that high?
It's not high enough to actually burn up on reentry, but it is going to come down and it's going to hit the ocean. It already has hit the ocean at some great velocity. It's not made to re-enter and splash down into the ocean.
So no recovery on any of this?
Not on the payload itself. I mean, they may be able to recover the parts of it and look to see why the fairing itself didn't open, but likely the impact will be substantial enough that the satellite itself will be probably inoperable.
Okay, now and these satellites, in that morning's news show I was telling you about, they talked about the cost and the loss of this. So what did it cost? I mean, this is a very expensive.
It is. It's an expensive satellite, and I'm glad you gave me the opportunity to kind of respond to that, because I'm going to take this a little bit different direction than our friends in the news media love to take it. Obviously, our friends in the news media love to throw that number out there, that dollar figure, to say, oh, this very expensive satellite, and this particular satellite would have been about $424 million to develop. This very expensive satellite, a $424 million spacecraft, failed to launch, splashed down into the ocean, was completely lost. Let me just remind folks out there about this one fact. We did not load up 424 million $1 bills on this spacecraft and burn them up in the atmosphere when they came back in. All of that money was spent on the Earth. Okay, it was spent. It was invested in hardware development, in technology development. It was invested in supporting scientists, supporting the research labs in which this rocket was discovered. All of that very, very good investment was made in people and in technology that still exist. Okay, so the idea is none of that was lost. The only thing that was lost was that ultimately the payload, which is maybe a few $1,000s worth of metal and hardware, and certainly that part did burn up and didn't come back in. The science mission obviously is not going to be achieved, but the money spent was spent in our economy and in developing technologies and supporting scientists that will turn around and add great benefit back to our economy. So,
okay, yeah,
so that's something that just needs to be kept in mind when we talk about that dollar
right.
figure.
Well, I'm glad you straightened that out, because sometimes that's all we hear of, all this money that's been lost all of a sudden and looks like a failure, and why should we be doing it? And people begin to question this. But that money was spent on all of those resources and people and industries.
That's exactly right. And the kinds of technologies that are developed for space flight and for these scientific missions, they have great spin-offs in the community. These are the same kinds of technologies that are used in medical imaging or in cell phone technology, communication technology, that add enormous benefit back to our economy and back to our society. And so that $424 million was spent in that arena before the rocket ever launched. And so that's the thing that needs to be remembered. It was not a $424 million loss. It was just $424 million was spent to develop the technologies that were on that satellite, but those technologies still exist.
So originally this was a climate satellite too, that was really going to monitor weather and really look at changes in the Earth.
Yeah, that's exactly right. And one thing it was supposed to monitor specifically was it was going to look at the relationship between the activity that takes place on the sun, and we're going to talk more about that later in the show, but that solar activity that takes place and how that affects the overall climate of the Earth. And so there's a big question in there when we talk about things like climate change and global warming. How much of that effect is caused by the sun? And that's something that's really not completely understood. And that was the purpose of this mission, was to go up there and investigate that. And obviously now it won't be able to do that particular science role at this time.
Right.
However, there are other satellites in development that are designed to be follow-ups to this mission that are already going to be developed and go up and investigate that very same scientific problem. So it's not like we even lost that completely out of the arsenal of science either.
Got it. Okay. Well, thanks for your insight into that.
You're welcome.
I gave you a platform there to straighten some
Thank
things
you very
out
much. I
that we
appreciate
don't
that.
always
My soapbox is what
hear.
it was called. Thank you
we
very
don't
much.
always get to hear this on the news, more explanation, and really
You
it's
almost
about
never
facts.
hear that argument in the
never
news,
hear,
actually,
You hear
so.
the sound bites about,
Exactly.
the sensationalism piece of it.
That's
So
right.
I appreciate that. Now, on the show we've been talking about the Discovery launch. We talked about that last week and so forth. Well, now they are at the space station.
They are.
They're docked.
The shuttle Discovery finally made it to the space
Finally
station.
made it.
How many
All
months,
this time.
Mike, have you and I on this show been talking about, well, someday they're going to get that Discovery satellite,
The leaks,
Discovery
the
shuttle.
wrench, the thing, yes,
it's going to
absolutely.
launch. It's going to go up
Talked
there
about
and do some stuff. Well, okay. So they finally got the launch successfully underway. There was a big piece of foam that came off and hit the underbelly of the shuttle. Looks like that's okay. So it looks like that's going to be all right. The shuttle did dock successfully with the International Space Station, and now at the filming of this show, they've actually completed their final spacewalks, which means they've gotten this new storage module installed on the external part of the International Space Station. They've gone and done some maintenance issues. They had a whole checklist of maintenance issues that had to be taken care of on the space station that they were able to go ahead and knock out. Here's a photograph of them right there unloading that storage module out of the cargo bay of the shuttle. That's
a great photo,
it's
too.
a fantastic photograph right there.
Great.
You can see that robotic arm grabbing that space module, and that's a storage. It's kind of a storage unit. It's loaded up with all kinds of supplies.
So just like our house here on planet, we made that storage unit in the backyard to put those lawnmowers and other things.
That's exactly right.
We're going to need that in space as well.
You might call one of your favorite temporary building establishments and have them come put that out in the backyard. However, these guys, when they need closet space, they have to fly the shuttle up there and
there you go.
install it.
A little more complicated.
And the funny thing about this closet is it came loaded already. Normally you put in a new closet, it takes some time for you to load that thing up with junk.
Fill it up with things. Yeah,
this thing came loaded with, I wouldn't say junk. This thing came loaded with supplies. And now what the astronauts are doing up on the International Space Station today is they are still continuing to unload all of the equipment and supplies that were loaded up in that storage unit and place them around the inside of the International Space Station.
Okay. And there are quite a few astronauts there.
There are a lot of astronauts there. That's right.
Space Station.
There are 7 astronauts from the shuttle, and there were 5 astronauts on the International Space Station already. So they're all up there hanging out together in the combined shuttle space station environment. And of course, the space station itself is now large enough. We've added enough modules onto it that you can have those large crews, and they can have some space to move about and kind of do the job and the work that they need to do. So they're all hanging out on the space station.
Oh, that sounds good. All right, so we've been talking in the last couple of weeks about Robonaut.
Yes.
And that's in the news. And
Robonaut's on the crew. He's up there with these guys.
Here we are again. But President Obama is talking about
Well, apparently President Obama likes Robonauts. So,
okay, all right,
so I guess the big news maybe is that the president made a phone call up to the International Space Station and spoke to both the shuttle astronauts and the space station crew. And here you can see him. There's President Obama seated at the desk. He's on the phone with the astronauts there. Just immediately to his right, or to our left on the screen right there, that's Charles Bolden standing there. He's the director of NASA. And so obviously some NASA officials there as President Obama made a phone call up to the astronauts on the International Space Station. And one of the things that he was doing, he was obviously congratulating them for their successful spacewalks. He was talking about the fact that they inspire the next generation of astronomers and scientists and engineers, which they clearly do. But one of the other things he told them is, hey, when are you going to unpack that Robonaut guy? Have you unpacked Robonaut yet? Is he out of the box? And as he made this comment, the commander of the shuttle mission, Steve Lindsay, said, well, we haven't gotten around to unpacking Robonaut yet. Robonaut's still in the crate. He's still in foam. And so the president kind of said, well, you need to set that robot loose.
You need to get that robot out of the box.
Get him working. So
that's funny.
The president's comments as he spoke with the space station crew. I think we have an actual shot of the space station crew, too. And you can see these guys talking to the president, men and women, actually. And so they're in the red shirts. These are the shuttle crew.
Oh, okay.
And the guy holding the microphone right there, that's the commander of the shuttle mission. That's Steve Lindsay.
Okay.
And then on your far left there, you see Alvin Drew. He was one of the guys that was out doing the spacewalk. We got a little bit more to talk about Alvin Drew here in a moment.
Okay, we'll come back.
But the folks in the red shirts, they are the shuttle crew. The folks in the blue shirts, I said 5 a minute ago. There were actually 6 space station astronauts. Those are the space station astronauts right there. And you see some big hair.
Yeah, I was noticing the lady's hair there, just on the right side of the screen. Did she do her hair just special for that picture?
She apparently watched the Young Frankenstein movie and did the... No, actually, we call this zero gravity hair. That's zero gravity hair.
That explains it. Okay,
so in the microgravity conditions that exist on the space station, if you let your hair down, it doesn't fall down.
Oh, it's
if you let your hair down, it goes up. All right,
okay.
or it goes out, I should say. It just kind of spherically goes out from your head.
Yes.
And that's what you're seeing right there. You're seeing zero gravity hair. So, but anyway, this is the press conference where they were talking with the president about that. And one of the other things I'd like to mention, one of the lead astronauts on those space station on the installment walks was Steve Bowen, and Steve Bowen was just added to the shuttle crew in January.
That's right.
And that's because the former lead spacewalker Tim Kopra had a bicycle accident
That's
right
right.
around the first of the year and broke his hip, and so was unable to go up on that mission. And so Steve Bowen had to jump in and basically learn all of the install procedures for what was taking place on that install of that storage unit, and figure out how to do all of the repairs and maintenance on the outside of the space station. And he led that spacewalk team, him and Alvin Drew together, and did that in very, very short period of time, since January, up to March. So that's a very short period of time. Normally they actually train for years before they go out and do these space missions, and he only had just a couple of months. So they were able to do that successfully. That's all very, very good news and an amazing accomplishment for
Excellent. And
those
so
NASA
the spacewalks are done now? How much longer will they stay on the space station?
They're actually going to be coming back for a landing on Wednesday. We're filming on a Friday. Okay. It's the following Wednesday that they'll be coming back down. The total time of that mission for the space shuttle team will be 2 weeks, so right at 14 days that they will go from launch to landing. And again, about 10 of those days they've spent up there. They'll be spending up on the International Space Station.
And of course, this is the last flight of Discovery.
This is the last flight of Discovery. When Discovery comes down and lands, it will actually have 365 days in space. That means that one spacecraft carrying astronauts has successfully had an entire year worth of time in space. 39 different missions to total that whole year in space, but a very, very successful spacecraft. After it comes down and lands, it's going to be the final flight for Discovery. It's going to be retired. Its new home is going to be the Air and Space Museum at the Smithsonian. So it'll be retired to the Smithsonian, where it'll spend its retirement years, allowing people to see that great spacecraft.
What a great craft to have all that great history with that. So that's wonderful. All right, so to move on to another story, we have something about super focus glasses. Very interesting concept.
Yes, indeed. It's a very interesting concept, and when you get to a certain age, you tend to have facial optics as part of your life. It just happens, and that's because the lenses in your eye, as you age, they actually get less flexible. And so So we call it accommodation. Those lenses have to be able to bend to focus at things both far away and nearby. And so as you get older, you lose the ability to be able to do that, and you end up with glasses of some sort.
Right.
And usually or you have various surgeries, or you have contacts or something.
Right.
But you need some kind of additional optical help. And what a lot of people end up with, they end up with these transition lenses, which are different places on the lenses. They have different parts of your prescription. So you look through the top to see far away, look through the bottom to see close up.
Right.
Or you just end up with bifocals, which is just, the
Right.
two different lenses in the same lens, down below or up top. Well, a new invention is these super focus glasses that have been invented. And the astronauts on the International Space Station on the shuttle flight actually were trying them out. Here's a shot of the super focus glasses.
Very interesting shot there.
It's a nice looking fashion pair. And what they actually have some fluid inside the lenses.
Okay.
And they have a little slider right on the bridge of the nose right there. And if you slide that slider back and forth, it actually changes some pressure inside the lenses and allows those glasses to be able to focus at different distances. So you almost think about it this way. If you ever used a pair of binoculars, when you look through the binoculars, you focus. You have a focus adjustment, and you can focus at different distances. Well, imagine being able to do that same thing for your glasses, where you could slide the slider one way to focus at something in the distance, or slide the slider the other way to focus at something close up, like a piece of paper or something like that you were trying to see close up.
Actually.
That's the super focus concept. And the funny thing is, to me, that they were being worn by shuttle astronauts as the astronauts tested out super focus glasses in space.
Okay.
This is Alvin Drew right here.
Yes.
And he's wearing
an interesting
those.
Picture of Alvin.
And again, they're very fashionable. Let me just tell you.
Right. Well,
being a glasses wearer myself, I'm thinking about getting a pair of those just because they look so cool.
Well, they are cool. They probably can work on that design just a little bit, Sean, maybe
Perhaps.
to help out with that. But the concept is absolutely wonderful.
Yeah, the science behind the concept is very, very cool. Now, let me tell you one last thing about Alvin Drew. He was wearing those super focus glasses as he was inside the shuttle. He was one of the spacewalkers. The funny thing is, he can't wear those glasses when he's out on a spacewalk. So I'm wondering how he saw. How he saw to know what he was doing, because he couldn't wear the super focus glasses outside. So what was he doing out there when he was actually on spacewalks? This is the question I have. These are the kind of burning questions I like to bring to this week in space science. How did Alvin Drew see to install the storage units on the outside of the International Space Station
without
hope
the super focus that storage unit is tight and in place there from Alvin's work. So
Alvin, if you're ever seeing this broadcast, first of all, I'm sorry.
We apologize for that.
Second of all, send me an email. Let me know how you did that, because I'm not really sure how you were seeing what you were doing without the super focus glasses.
All right, so this next story is about meteor fireballs.
Mike's moving on to the next story.
That's what I'm saying. We just can't see from here, but what about the meteor fireballs?
You want to know about meteor fireballs?
I'll
tell you about meteor fireballs.
Right,
actually, there's the scientist at the Marshall Space Flight Center in Huntsville, Alabama. His name is William Cook. Bill Cook, we know him as. One of the things that Bill Cook is studying for years are the 100 tons of meteoritic debris that fall in on the Earth every day. Let me say that again. 100 tons of space debris, natural space debris, falls in on the Earth every day. Sometimes rockets fall in too. That's kind of man-made. We're not talking about that. That's not part of the 100 tons. And so the idea is that most of the stuff as it falls in, it's dust or grain of sand-sized particles. It really doesn't have much effect. But once in a while, chunks that are bigger fall in on the Earth, and as they fall in through the atmosphere, they streak across the sky and make a bright flash of light. Here we can see what's called an all-sky camera. It's a big fisheye lens that's looking up there at the nighttime sky. And you can see that streak of light moving right through the middle. By the way, what's that bright light over on the bottom left? That's the moon. Okay. So the moon's down there on the bottom left, but the streak of light you see toward the center of that shot right there, that's actually what we call a fireball or a bolide streaking across the sky, making a very bright light as it enters into the atmosphere and burns up in the atmosphere.
Pretty good size too, isn't it, Sean?
Yeah, that must have been a little bit larger chunk. It's obviously not a grain of sand-sized piece streaking across there. Well, what William Cook has done is he has organized a whole fleet of robotic fisheye telescopes like the one you just saw there to constantly monitor the sky east of the Mississippi River. So there's going to be 15 of these all-sky cameras that are placed in positions where they can monitor the sky strategically, so that anything that might fall in the eastern United States is going to be captured by one of these robotic telescope cameras somewhere. And all that data then funnels back to the Marshall Space Flight Center, to the team that Bill Cook is in charge of, so that he literally wants to be able to see anything that falls into the sky
right.
and keep track of everything, simply everything that comes in and makes a bright streak across the sky.
Bill wants to track all of this
Bill
debris, meteors, whatever might come in there.
Yes, he does. He wants to keep an eye on the sky to know what's falling in over the eastern United States. I think it's kind of a cool project.
I kind of appreciate Bill in keeping an eye out there.
We want to know. People want to know what's falling in into the sky in the nighttime. So Bill Cook's going to be the person who's going to be able to tell.
All right, now it's another story. We talked about Virgin Galactic many times on this program. They're in the news again.
Virgin Galactic's in the news again for a very cool reason. Virgin Galactic, of course, is that's the company that has developed space tourism as their concept. Richard Branson is in charge of the Virgin Empire. Virgin Galactic, one component of that empire.
I'm saving up my money. I think at one point you told me it was about 350,000.
It's down from that. It's 200,000.
200,000.
So a mere 200,000, and you could fly on Spaceship Two to a suborbital flight in space. And when we say suborbital, that means it's getting up just high enough that you're actually in space. You'll experience zero gravity for a little while as the spacecraft arcs over to come in on re-entry, but you will not orbit the Earth. Okay. However, that short time in space is long enough to actually do some real science. And the reason that Virgin Galactic and Spaceship Two is back in the news right now is because they've actually sold some seats on their upcoming flights, not to just average space tourists. They're going to go up like a roller coaster and lift their hands in the air and go, whee, I'm in space. But to actual scientists at the Southwest Research Institute in Colorado who want to investigate the effects on the human body in zero-G.
Right.
They want to investigate the upper part of the atmosphere, and they want to be able to do some imaging of the ground from a high altitude. So these are real science objectives. There's some science going on with Virgin Galactic and Spaceship Two. So that's very good news. That's about $1.6 million in contracts also for Virgin Galactic. So that's another guaranteed set of money for them to fly these folks in space.
Working out on this private venture.
That private venture seems to be going very successful. They have about 400 people that have put down deposits on their upcoming flights. So if you think about that, that's a very good and lucrative business that's being set up by Virgin Galactic to take folks up on Spaceship Two up to suborbital. So we're looking forward to their upcoming missions in the near future.
I'm assuming that they will video and film this, and as they want to expand their business, that maybe perhaps we'll have some opportunities to see some of that Virgin Galactic video footage and maybe bring it in one of your next shows.
I absolutely know that they will be promoting this in any way possible.
Absolutely.
With that entrepreneurial spirit that has allowed Richard Branson to achieve the level of success that he has achieved.
Very interesting fellow. We've talked about him several times, Richard Branson there, carrying on with some stuff. All right, final event we're talking about, a solar wind, a very strong solar wind.
Yeah, there's some extra activity going on in the sun right now. That's because the sun goes through cycles of activity. It's been at a low part of its cycle for a while now, but this 11-year cycle is starting to ramp back up again, so we're now seeing more solar storms on the sun. We're now seeing more sunspots. We're now seeing more of what we call coronal holes. These are holes in the corona that allow the solar wind to stream out at a very high rate of speed. And when you have these extra events on the sun, you get more solar radiation pouring into the Earth's atmosphere. As it comes into the Earth's atmosphere, it's captured by the Earth's magnetic field. Those extra particles are drawn in over the poles, the North Pole and the South Pole of the Earth. They come down and they contact the atmosphere of the Earth at a high rate of speed with some extra energy, and they cause the air to glow. Well, when the air is glowing over the North Pole and over the South Pole, we give that a name. Over the North Pole, people know that as the Aurora Borealis, or the Northern Lights. And this is a beautiful Northern Light display.
Shot there,
it's a gorgeous display that was photographed in a place called Poker Flat, Alaska. This photograph was taken by a NASA space physicist by the name of James Spann. James Spann shot this beautiful photograph of particles coming in from the sun. Remember, this is all triggered by the solar activity. Particles coming in on the solar wind, impacting the Earth's magnetic field, then interacting with the atmosphere and causing the air to glow. Now, when we see green light, like in that photograph right there, the green light means that that's oxygen in the atmosphere that's being excited. And so anytime we see green within the process of the Aurora Borealis, we know that the oxygen atoms are being excited. That's one of the most common. There's obviously a lot of oxygen in our atmosphere, so that's one of the most common kinds of lights to be able to see is that green color.
That's a good bit of information to know about.
It's pretty cool stuff. So you see that green light in these aurora photographs, you know it's oxygen. Okay.
All right. Well, I tell you, we've run through a lot of stories so far on this show. It's a lot of information. I hope people are keeping up with this. But, all right, closer to home, the Coca-Cola Space Science Center here in Columbus, Georgia, at Columbus State University.
A good place to be.
Excellent place to be. All right, so what kind of events? What do you have on your calendar?
Well, the first thing I'm going to do is tell you not to go to the Coca-Cola Space Science Center. I'm going to tell you to go out.
Hold on a second. What?
I'm going to tell you to go out with our mobile astronomy team. That's why I'm kind of teasing that a little bit. But on this Saturday night, we're going to be out at a great place called Providence Canyon State Park.
Excellent.
One of our very favorite sites to go to because it gets out away from city lights and allows you to see the dark nighttime sky right over the canyon. It's a beautiful place to be anyway, but it's a great site for us to go out with our telescopes and observe. We're going to be out at Providence Canyon State Park on Saturday night, March the 5th, and we're going to be out there about 7 p.m. starting up. Dr. Rosa Williams and the astronomy team will be setting up their telescopes and doing a PowerPoint out there to show you what you will be able to see. And then once the sky gets dark, setting up the telescopes and actually showing you things in the nighttime sky. There's some great stuff in the sky right now. The Orion Nebula happens to be up this time of year.
Oh, yeah.
That's a beautiful sight to be able to see in these early springtime skies because it's in a very convenient position to be observed. It's one of my favorite objects to look at. There are many, many more objects out there. I think planet Jupiter is going to still be around and be visible and observable at this time. So those two objects alone would be worthwhile getting out there and seeing with the telescopes. But many, many more objects are going to be visible. Dr. Williams and the astronomy team, they'll tell you all about what you'll be able to see in that nighttime sky. So go out and join the team, and you can see the heavens for yourself out there at Providence Canyon State Park.
You know, and people may not know this, but you bring a lot of telescopes.
We
There's a van full of telescopes.
A van full of telescopes. That's exactly right. We bring out a whole fleet of telescopes, and we have everything from 8-inch telescopes. That's the diameter of the mirror, by the way. 8-inch telescopes to 10-inch telescopes. We even have a 14-inch truss tube telescope that we're now taking out to our mobile astronomy programs. They'll bring out the big 14-inch, and that's a great telescope to be able to see the nighttime sky with. Really has a large mirror, allows you to make those images nice and bright so those objects out there are very easy to see in that 14-inch telescope. So that's kind of the mobile astronomy fleet as it goes out and shows people the nighttime sky.
Excellent. I recommend it for everyone. All right, Stars of the Pharaohs.
Yeah, we have a show that we are reviving for our planetarium, the Omnisphere Theater. We are running Stars of the Pharaohs right now. It's a great show. It's narrated by John Rhys Davies, the actor, the Hollywood actor. Okay. A lot of people know him as Gimli from Lord of the Rings, or maybe you know him as Sala from the Raiders of the Lost Ark series.
Okay.
Or maybe you know him from Sliders, the TV show. A lot of places that John Rhys Davies.
You followed him very well.
I've tried to follow his career because he's got one of these kind of amazing voices. He does. He's a perfect voice for narration. And so he narrates a show about his homeland, Egypt, and it's called The Stars of the Pharaohs. It's a great show to see because it talks all about the history of Egyptian astronomy and how they viewed the sky in ancient Egypt. It also does a great job of taking some 3D flights through some of the most famous monuments of ancient Egypt and how they would have looked at the time when they were new. So that's a great thing to be able to see.
Great.
And so you learn a little bit about Egyptian history. You learn a little bit about astronomy. You get to hear about what the pharaohs thought about the nighttime sky. And very interesting stuff.
If one of our viewers is out there and they want to know how to get in touch with you, where to go to find more information about this, where would they go? What would you tell them?
Well, what I would tell them is to go to our website. That's the best place to find out information about the Space Science Center. It's just our initials. We're the Coca-Cola Space Science Center. So our website is ccssc.org. We're a nonprofit organization. So Coca-Cola Space Science Center, ccssc.org. Or I tell people, if you don't like to remember it that way, remember charlie.charlie.sam.sam.charlie.org.
Charlie, Sam, Charlie. I think I can remember that.
I'm hoping people will be able to remember that. We have no one named Charlie or Sam that actually works at the Space Science Center. But if you remember charlie.charlie.sam.charlie.org, you'll be able to get on that website and find out all the info about the Coca-Cola Space Science Center.
Oh, you got to go there. You still have more things to talk about.
Well,
You've got something about Sesame Street.
Yeah, if you have a little kid, they may not like the Stars of the Pharaohs show too well if they're in preschool or maybe first or second grade. Right. But there's a show that's ideal for that group. It's called the Sesame Street Show, and Big Bird and Elmo explain all about some of the constellations, the Big Dipper, how the moon looks in the sky, what you might look for, what it might be like to be jumping around on the surface of the moon. You get to see Elmo singing, dancing, and jumping around on the surface of the moon. Ladies and gentlemen, that's entertainment.
All right, now that's where we need to. We need to go see that. Absolutely.
That's the Sesame Street Show running in the Omnisphere. That's for the younger crowd. And also we have our information all about summer camps. And this time of year, it's getting to be springtime. You got to be thinking about what the kids are going to be doing during the summer. You got to plan ahead. Get on the Space Science Center's website. You can find out all of the summer camp lineup. There we have a great lineup of camps that we offer each and every summer. Go to the website, click on that summer camp icon, and it'll tell you all about the summer camps we have coming up at the Coca-Cola Space Science Center.
Well, Sean, here we are again. I mean, this has been a wonderful show. There's the, and the great graphic art you guys have down there. We talked about that.
That artwork is done by Chris Johnson, by the way. He's our web developer, our graphic artist, and our IT specialist.
Shout out to Chris on that.
But
that's
my
a great
goodness,
job.
he is a
yes.
very, very talented artist, and of course, his little alien buddy down there. That's a character he developed specifically for the Space Science Center.
Yeah, the little green guy.
The little green guy.
Yeah, there he is.
That's
coming
exactly
out of
right.
that
So,
all right.
so I guess those are summer camp kids in their astronaut suits, climbing all over the surface of Mars and running into our green alien friend on there.
I love it, actually. Very great. Well, Sean, here we go again. We've just finished another This Week in Space Science, a great show, a lot of information. Thank you so much for bringing all this information to our viewers. I know they appreciate it,
Thank you,
as we do.
Let me put in one last plug. If
Yeah,
you're interested in a career in engineering or environmental science or geology,
yes, that's right.
you can come to me at the Department of Earth and Space Sciences and find out about all of those majors. And if you're out there listening, maybe the major you're in is great, but it's just not for you. You can find out all about the information, these other majors on campus at our website for the department, which is ess.columbusstate.edu. So get on that website and find out all about those majors as well.
Excellent. I'm glad you put that in
Thanks,
there.
Mike. I appreciate it.
Yeah, no problem. All right, ladies and gentlemen, thank you so much for tuning in this week to This Week in Space Science with Sean Cruz. We'll see you next time. Thanks for viewing.